Hello friends, today we are going to discuss the part 2 of this continuity and differentiability chapter. So in this part I am going to show you how we can understand by the graph, okay, any function is continuous or not. Okay, so let's have one function. So we are drawing the graph of y is equal to mod x, and I have shown you in the previous video that how this y is equal to mod x is written, like y is equal to x when x is greater than 0, y is equal to minus x when x is less than 0, and y is equal to 0 when x is equal to 0. Okay, so we can draw the graph of this this all. Actually there are three functions: y is equal to x, y is equal to minus x, and y is equal to 0. Okay, so if you see, if you draw the graph of y is equal to x, which is very easy actually. So basically you can draw x minus y is equal to 0, because this y will go into the right hand side, it will become minus y. So you can take the points, or you can use this slope intercept form. Okay, it is not slope intercept form, it is intercept form actually only. Okay, we can draw the graph directly also, but we are taking the points to draw the graph to for better understanding. Okay, so like suppose x is equal to 2 or x is equal to 0, right? So the y is 0, x is equal to 1, so y will be also 1, so y will be 1 here. If x is equal to 2, y is also 2, so it will be here. So you see it will pass through the origin and it will go like this. Okay, because if you take x is equal to minus 1, then y will be also minus 1. Okay, so it will be in the negative x-axis. Then like if you draw the graph will go like this. Okay, it will be, it should be a straight line. Okay, it should not be like a bent. Okay, so we will draw it carefully, and once we will draw the graph, any graph, so we have to draw it in a graph paper. Okay, that we need to be care about. This is 1, this is mine, this is 1, this is 1, this is 2, this is 2, and this is minus 1, this is minus 1, this is minus 2, this is minus 2. We have taken this as minus 2, minus 1. Okay, but if you draw the graph of y is equal to minus x, what will happen? The graph will be like this. Like y is equal to minus x means y plus x is equal to 0. So means your x is equal to 1, then y is equal to minus 1, means x is equal to 1 here, y is equal to minus 1 here. Okay, here. So and when x is equal to 2, your y will be equal to minus 2. So it will be reverse, x is equal to 2 here, y is equal to minus 2 here. Okay, so then the graph we can draw. You see this, we have got these 2 points. We can, and as we know that if your x is 0, y is also 0, so this graph will go like this. Okay, as you see the graph is crossing each other, right? So here, and so what, as we have seen in the concept of mod x, according to the mod, y should be always positive, right? So all the negative value of the y, which is you see in the downside, right, this is all negative, so this will be cross, means we will just erase this portion. Okay, we'll erase this portion. Okay, and we'll be drawing only the uh, above y, this portion, this is called plus y, right? This is plus y. So the actual graph of mod x is like this, which I am drawing is, in a red pen, like this one. Okay, this is the y is equal to mod x graph. And you see in this graph there is no such in the domain of the y is equal to mod x. So domain is like the value of x for which the whole y will be defined. So we are finding actually continuity in that domain only. So if you see in this domain we are finding one point, y is equal to 0. So this is the y, this is the 0, right? So at this 0 you see the graph is not discontinuous, means the flow is there as it is, right? Discontinuous means there should not be any gap. Okay, so that is means this is continuous at x is equal to 0. Okay, but the y, the coordinate of y changes, it is totally positive. Okay, that's how we can do. I'll tell you more on this in the next lecture. I'll take other examples. Okay. Okay.